9. Understood, all of you? Done. All of you understood this? Let's try one more. Any problem to anyone in the last question? If energy of second orbit of hydrogen is minus 328 kilojoule per mole, then energy for fourth orbit will be how much? For second orbit it's given, for fourth orbit it is asked. How much it will be? How is that, Pratyusha? What you have done? 0.13 into 10 to the raised power 8. Very good, Kimaya. Shouldn't it be minus 0.82? Amba, why you multiplied by 4? E is directly proportional to Z square, inversely proportional to N square. All of you. This is the formula we are having. This is constant. So E is directly proportional to Z square, inversely proportional to N square. That means E1 by E2 will be Z1 square by Z2 square into N1 square N2 square. Whatever formula you use, Pratyusha, here energy value is already given. You do not have to take care of its own. It's given. Now Z1 equal to Z2 equal to 1, क्योंकि ये हाइड्रोजन के लिए है. So this will get cancelled out. N2 is your 4 square, N1 is your 2 square. 16 by 4. 4. So E2 will be equal to what? E1 by 4. E1 is minus 328. 4 से divide कर दो. It will come out to be 8 4 32. 8 2 48. minus 82. Very good, Kimaya. Jared, Rebecca, Komal, Deepika, Pooja, Rebecca, Pooja, Jared, understood, Shivangi, sir, whenever value is given, we use this ratio to obtain the term. Yes, Pratisha, that we have to do. Deepa, Rebecca got it. Energy of first excited state of He plus is X, then energy of second excited state of Li2 plus will be how much? Am I audible? Am I audible? So much of time you have taken. Kimaya is saying X only. Komal 9x by 16. Jared X. Deepika 9x by 16. Shivangi X. Sejal X by 3. Amba X. Let's see. Again, I say energy is directly proportional to Z square by N square. Now, E1 by E2 will be equals to Z1 square by Z2 square into N1 square by N2 square. What is your Z1? Helium. Helium matlab 2. What is your Z2? Lithium. Lithium means 3. First excited state का मतलब n equal to 2. Second excited state का मतलब n equal to 3. Any problem to anyone in excited state and their Z value? Any problem to anyone in excited state and Z value? Adric, Sejal, Deepika, Komal. Any problem to anyone in Z and N value? All of you understood what do you mean by excited state? In case of excited state, we have to take n plus 1 value. If it is your second excited state take 3. If it is your third excited state, take 4. That's it. So Z1 square by n1 square, z2 square, n2 square. ये तो सब कट जाएगा, मतलब E1 बराबर E2, so it will be x. Understood? I know, that's what I'm saying. All of you done? All of you understood the new one also? एक और देख लेते हैं. In a hydrogen atom, if the energy of electron in the ground state is minus x electron volt, then that in second excited state of He2 plus He plus will be, in a hydrogen atom, if the energy of electron in the ground state is minus x electron volt, then in the second excited state energy will be how much? Minus 4 by 9. Which of the following is correct? Which one is correct? C is correct. कैसे? Let's take the first question first. इसको A बोल देते हैं, इसको B बोल देते हैं. Let's take A first. Energy of electron in ground state. So हम कह सकते हैं E1 by E2 will be Z1 square by Z2 square into N1 square by N2 square. Okay. Z1 is how much? Hydrogen atom, so it will be 1. Helium atom, so it will be 2. So square, square. First one ground state, so 1 square. Second excited state, matlab 3 ka square. So it will become 9 by 4 is equals to E1 by E2. E1 is X minus X into 4 by 9 will be E2. So the previous answer was minus 4 by 9 electron volt. Very good, Rebecca, Sejal, Shane, Archana, Kimaya, Deepika, Pooja, Jared. Very good. Any problem to anyone in the previous question? Any problem to anyone in the previous question? Okay, Jared is saying A for this question. Pooja, Deepika, Pratyusha are saying C for this question. Let's see. Do we know what is E1? E1 is how much? E1 is minus 13.6 electron volt. E2 is how much? Minus 3.4 electron volt. E3 is how much? Minus 1.51 electron volt. E4 is how much? 0.85 electron volt. Minus that. So E2 minus E1 will be how much? Minus 3.4 electron volt plus 13.6 electron volt मतलब 10.2. E3 minus E2 कितना होगा? Minus 1.51 plus 3.4 electron volt मतलब 1.9 electron volt. और E4 minus E3 will be how much? 0.85 minus plus 1.5. This will be plus 0.65 electron volt. That means Jared was right. E2 minus E1 is bigger than E3 minus E2 is bigger than E4 minus E3. मतलब Jared was correct. अच्छा ये E2 है. This was E3. Is by mistake. Okay. इसीलिए आपका आंसर गलत हो गया. Actually it was E3. By mistake मैंने E2 लिख दिया. Sorry for that. This will be E3. And then first one is correct. Okay, Amba, Shane, Archana was correct. All the three, Pooja, Deepika, Pratyusha. All of you understood this part? Those who are joining now, please go through the quantum number topic. It is one of the most important topics of this chapter and will come in the other chapters as well. So please take the notes and complete that quantum number topic. That will be very much important as we have done 11th and 12th class. You know that it will come in the next chapter also, next to next chapter also, and in the coming chemistry part, block also. S block, P block, D block, F block, all based on quantum number. So please take the notes and complete that. Understood? Okay, if you're not getting notes, then let me know. I'll put this PDF on the post. ठीक है, इसे छोड़ देते हैं. What does the negative value of total energy of electron means? What does the negative value of total energy of electron means? नेगेटिव वैल्यू से क्या मतलब है? Why do we have that negative value? Why it is not positive? Giving out energy, attraction of electron to the nucleus, exothermic. Exothermic नहीं होगा यार. Attraction of electron to the nucleus. Okay, somewhat correct. Giving out energy. No, it will not be exothermic. It will not be giving out energy. Somewhat it is related to attractive force, as Rebecca and Pratyusha said. See, if this is your n equal to 1, this is your n equal to 2, this is your n equal to 3, here energy is minus 13.6 electron volt, here it is minus 3.4 electron volt, here it is minus 1.51 electron volt, and here you have nucleus. We will say negative energy means electron is bounded to the nucleus. Very good, Rebecca. Electron is bounded to the nucleus by this much amount of energy. Electron is bounded to the nucleus by this much amount of energy. Negative sign means electron is bounded to the nucleus by this much amount of energy. Negative sign means electron is bound to the nucleus by this much amount of energy. Electron is bounded to the nucleus by this much amount of energy. So can we say electron is becoming more free as it go away from the nucleus? Electron becomes free as it goes away from the nucleus. Can we say electron becomes free as it go away from the nucleus? Because here it is bounded by 13.6 electron volt. Negative sign तो bound के बारे में बता रहा है. Magnitude is 13.6 electron volt. Then electron is bounded by 3.4 electron volt. Then electron is bounded by 1.5 electron volt. And it becomes more free as it go to higher orbit, that is away from the nucleus. Okay, so minus sign says that electron is bound to the nucleus by that much amount of energy. And you can see the magnitude is decreasing, so electron is becoming more free as it goes away from the nucleus. When it will become completely free? When it will become completely free? Infinite पर. Infinite तो कुछ नहीं होता. तो can we say electron will never become free? Can we say electron will never become free? क्योंकि infinite तो कुछ होता ही नहीं है. This energy, कौन सी energy? Binding energy will become free, sorry, zero only at n equal to infinity, which is hypothetical. Hypothetical. So electron is always remain bounded to the nucleus. All of you understood this. Negative sign means that electron is bounded to the nucleus by that much amount of energy, and that particular magnitude of energy is decreasing as we go away from the nucleus. It will become completely free at n equal to infinity, but that is an hypothetical value. That means electron will never become free on its own. Very good, Pratyusha. I was coming to that only. Matlab, it will never become free on its own. It will never become free on its own. Understood? But when some external energy is applied to it greater than or equal to binding energy, then electron can eject out. That energy is called ionization energy. Ionization energy. Understood? Will it always be positive? Will it always be positive? As you are applying energy, it will be a positive value. Any doubts till here? Read it from the question till here. First, read it from the question. Please mute your mic. Who's this? Please mute your mic. Am I audible now? Sorry. Total energy of electron increases as we go away from the nucleus. True or false? E1 is minus 13.6 electron volt. E2 is minus 3.4 electron volt. E3 is minus 1.51 electron volt. Matlab energy is increasing. It is a true statement. It is a true statement. Binding energy of electron increases as we go away from the nucleus. True or false? True or false? Binding energy is 13.6 electron volt, 3.4 electron volt, 1.51 electron volt, 0.85 electron volt. It is decreasing, so it is false. Maximum total energy of electron and minimum binding energy of electron is of electron is zero. True or false? Maximum total energy of electron and minimum binding energy of electron is zero. True or false? ये डिक्रीज करते 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 मैक्सिमम मतलब ई इंफिनिटी पे कितनी हो जाएगी जीरो. ये डिक्रीज करते 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 ई इंफिनिटी पे कितनी हो जाएगी जीरो. दैट मीन्स इट इज ट्रू. All of you understood this? All of you understood this? Any problem for anyone? Komal, I said maximum total energy of electron. As you can see, this value is increasing. This value is increasing as we are increasing n value. Maximum n value can be infinity और माइनस धीरे धीरे डिक्रीज होगा. क्या बन जाएगा जीरो. So when n is your maximum, E will be zero. This value is decreasing. So if it is decreasing, minimum it will be zero. That will be at infinity. That's what we have written. Ionization energy. Amount of energy required to remove an electron from ground state and throw it to n equal to infinity out of the atom. Amount of energy required to remove an electron from ground state and throw it to infinity out of the atom. So can we say ionization energy will be E final minus E initial? E final minus E initial. E final will be how much? Minus 13.6 electron volt into Z square by infinity square minus 13.6 electron volt into Z square by ground state. Any doubt in this? Any doubt in this? इसे solve करेंगे, this will become 0. This will become 0. 0 minus 13.6 electron volt divided by 1 square is 1 only into Z square. If there is no excited, inexcited will be apply the same law. Except then we'll say it is excitation energy. Pratyusha, I'll come to that after this topic. Then it will be called excitation energy. So this will be plus 13.6 electron volt. That's what I have written, Jared. But multiplied by Z square will also be there. Z square will also be there. Any problem to anyone? Can we say ionization energy depends only on the atomic number? Ionization energy depends only on the atomic number. Ionization energy depends only on atomic number, not on n value. Because we know we will always take it from the ground state. Understood? Any problem to anyone in this? Any problem to anyone in this? ठीक है, ट्राई करते हैं. Calculate the amount of energy required to remove third electron of lithium ion. लिथियम का थर्ड इलेक्ट्रॉन निकालने में कितनी एनर्जी लगेगी? वन 2.4 30.6 इलेक्ट्रॉन वोल्ट। कोमल ने आई थिंक डायरेक्ट फॉर्मूला लगा दिया है, प्रत्युषा ने दिमाग भी लगाया उसके अंदर। अर्चना इज गिविंग डायरेक्टली 13.6 इलेक्ट्रॉन वोल्ट, वो जेड से बात ही नहीं कर रही है। ऐसा क्यों कर रहे हो यार तुम? देखो, आयनाइजेशन एनर्जी इज माइनस में 13.6 इलेक्ट्रॉन वोल्ट into Z square. Z will be equal to 3 for lithium ion. So it will be 13.6 into 9. Not 122.4 electron volt. Okay. Now, what Pratyusha has done, I think she has divided it by some value. प्रत्युषा आपने क्या किया? डिवाइड किया इसको 4 से। And Archana, आपने क्या किया? Why you divided it by 4, Pratyusha? Now the problem is, you may think that we are talking about electron. Now what I am saying is, we can only talk about third electron. इसीलिए हमें और कुछ नहीं सोचना है. We can only talk about third electron. Pratyusha, listen to this carefully. We can talk only about third electron. Why? Because Bohr theory is not applicable on lithium. Is Bohr theory applicable on lithium? Deepika, Pratyusha, please listen to this carefully. Is Bohr theory applicable on lithium? That means you cannot tell how much energy required to remove first electron. Is Bohr theory applicable on Ni plus? Is Bohr theory applicable on Ni plus? Is Bohr theory applicable on Ni plus? No. Li plus का मतलब 2 इलेक्ट्रॉन हुआ ना यार. Li plus means 2 electron. So you cannot say how much energy is required to remove second electron. Is Bohr theory applicable on Li2 plus? Yes. Bohr theory is applicable only on Li2 plus. So we can calculate only for the third electron. So the formula which is given to you, that is for the third electron only. जो फॉर्मूला आपको बताया है वो थर्ड इलेक्ट्रॉन के लिए ही है. So I should better write here last electron removal. Now things will become more clear. Okay, Pratyusha and Deepika. Deepika, Pratyusha, Archana. So your formula is applicable only for the last electron. तो हाइड्रोजन के लिए we can calculate first electron. हीलियम के लिए we can calculate second electron. लिथियम के लिए we can calculate third electron. कार्बन के लिए we can calculate sixth electron. बोरोन के लिए we can calculate fifth electron. Kind of. Neon के लिए we can calculate 10th electron. Understood. Understood. तो आपको और बिल्कुल दिमाग नहीं लगाना है. The question will be given to you in such a way that you just have to put the formula and get the answer. All of you understood? किसी से डिवाइड नहीं करना, मल्टीप्लाई नहीं करना, नथिंग. मतलब calculate the amount of energy required to remove fifth electron from boron. Fifth electron from boron. Fifth electron from boron. Komal, you didn't answer. Siddhi, Pooja, Shivangi, Sejal, Deepika, Pratyusha, Shane, Kimaya. So ionization energy will be 13.6 electron volt into Z square. Z square कितना हो जाएगा? 25 into 13.6 electron volt. 100 by 4 into 13.6. That means 1360 by 4. So आ जाएगा 340 electron volt. Very good. Understood, all of you?
So I had a question.
Yes. Yes.
So for this one, what you said, like we always use it using like H plus species, right? I mean, like hydrogen like
Okay.
species. So like, but
Yes. Yes.
now, why don't we actually divide it? Like we are saying it's like the fifth electron. Now you said in boron. So like
Okay.
why don't we actually divide it? Because it's just like the last electron. That's why.
No, it is the only electron. It is behaving exactly like the hydrogen. Whatever we have done for the hydrogen, we'll do same thing for this. It is nothing Now nothing is left different from hydrogen. However, hydrogen is behaving, this will behave like exactly same.
But now in case like they say like calculate the amount of energy required to remove the fourth electron from boron, then which
Yes.
then what would we do
Then
there?
then we won't be able to apply the formula only. We do not know anything about it then.
So then we'll just write infinity or something.
No, we cannot say anything then because Bohr didn't know anything about such, didn't know anything such thing like he fourth के लिए क्या होगा, third के लिए क्या होगा. He was only knowing about the last electron. He only discussed everything for the single electron species.
Okay, so that means like whenever like everything he'll ask is always related to the last electron value, like.
Yes, yes, he
Okay.
will always ask for the last electron, single electron. Otherwise, the topic will go to the next chapter, that is ionization energy. There they will provide you the energy. It is an experimental observation.
Okay, so like it's always
Okay.
for hydrogen-like species. Only the last electrons
Yes.
comes.
If the
Okay.
question is from the Bohr spectra, Bohr theory, they can only ask you for the single electron species. Otherwise, they cannot ask only.
Okay, so yeah, got it.
Okay,
Yeah.
because we are not considering any shielding force.
Hmm. Yeah.
We are considering that electron is tightly attracted by the nucleus, but we know if there are some intermediate electrons, then those electrons will shield the last electron,
Yeah.
right? So
Yeah.
less energy will be required. But Bohr didn't know anything about such, didn't know anything like that. He simply said there is only one electron and nucleus, so they are attracting each other. So whatever question comes from Bohr theory will be for the last electron only. Otherwise, we cannot say anything.
So that's why you said like it does not depend on the n value at the end.
See, here n is the orbit in which we are talking about.
Ah.
Here n is not which electron we are talking about. N is the orbit that we are talking about. And we have already said that we are removing the electron from the ground state. And ground state means n
Oh.
equal to 1. So 1
Hmm.
square will always be 1. No need to put that n and all.
So ground state it's always one,
Yes, ground state means 1.
but now like that also like boron it's the fifth electron, so that will come in the second orbit, right? So that is also considered as ground state only.
We are not talking about boron.
Hmm.
We are not talking about boron. Boron had 5 electrons, right?
Yeah.
Now boron was 1s2, 2s2, 2p1, right?
Yeah.
Now this electron has been removed. We do not know how much energy has been required.
Hmm.
Okay.
Yeah.
This electron has been removed. We do not know how much energy is required.
Hmm. Yeah.
This electron has also been removed. We do not know how much energy has been required.
Yeah.
Okay. This
Hmm.
electron has also been removed. We do not know how much energy has been required.
Okay. Yeah.
So we have already removed 4 electrons from the
Hmm.
outer shells, and we do not have any information about it that how much
Hmm.
energy was required. We can
Hmm.
only talk about this electron,
The ground state one.
and where it is present in the ground state.
Okay. Now I got it.
Understood? Even
Yes.
if I talk about the neon, then we
Hmm.
cannot talk about the last 9 electrons. We can only talk about the 10th
First electron.
electron, which is
Yeah. Yeah.
again present in 1s1.
Okay. Yeah.
Okay. Yeah.
Yeah. Thank you.
Okay. All of you understood this now?
एक्सक्यूज मी सर
Yes.
सर मतलब जब भी क्वेश्चन पूछेंगे तब
Hmm.
वो एटम हमेशा ग्राउंड स्टेट में होगा.
हाँ, बोहर बोहर का अगर क्वेश्चन है तो हमेशा एक ही इलेक्ट्रॉन की बात होगी और वो मतलब अगर आयनेशन एनर्जी के बारे में बात हो रही है तो ग्राउंड स्टेट में ही होगा.
ओके सर.
अदरवाइज दे विल यूज डिफरेंट वर्ड. जैसे मैं आपको देता हूँ अभी सेपरेशन एनर्जी. सेपरेशन एनर्जी में क्या होता है, यू आर नॉट रिमूविंग इट फ्रॉम द ग्राउंड स्टेट. उसको सेपरेशन एनर्जी के अंदर यू आर रिमूविंग इट फ्रॉम एनी अदर एक्साइटेड स्टेट. बट वहां पर क्वेश्चन में डिफाइंड होगा विच एक्साइटेड स्टेट दे आर टॉकिंग अबाउट. दे कैन टॉक अबाउट n equal to 2, दे कैन टॉक अबाउट n equal to 3, लेकिन वो क्वेश्चन में गिवन होगा. कि आपको यहाँ से इलेक्ट्रॉन निकालना है।
हाँ, ओके सर।
अंडरस्टूड। लेकिन आयनाइजेशन एनर्जी में गिवन नहीं होगा। क्यों नहीं गिवन होगा? क्योंकि आयनाइजेशन एनर्जी का मतलब आप ग्राउंड स्टेट से इलेक्ट्रॉन निकाल रहे हो।
हाँ, लास्ट।
अंडरस्टूड।
हाँ,
यस
यस सर, थैंक यू सर।
तो सेपरेशन एनर्जी, separation energy, separation energy, amount of energy required to remove an electron from any excited state, to out of that or to infinity. इस बार हम क्या कर रहे हैं? वी आर टेकिंग इलेक्ट्रॉन फ्रॉम एनी एक्साइटेड स्टेट टू इंफिनिटी। अंडरस्टूड। तो आपकी सेपरेशन एनर्जी क्या हो जाएगी? एनर्जी एट इंफिनिटी माइनस एनर्जी एट एनी एक्साइटेड स्टेट। Okay, so minus 13.6 electron volt upon infinity square into z square minus 13.6 electron volt into z square upon n square. We do not know which n they are talking about, but yes, this will definitely become 0. So 0 minus something which is negative will make it positive. So this will become 13.6 electron volt into z square upon n square, the excited state we are talking about. Understood? ये separation energy है. If you are not removing electron from the ground state, but you are removing electron from any excited state, then that energy will be called separation energy. Any problem to anyone in this? Now we are removing the last electron only, but we are not removing the last electron from the ground state, but from some other excited state. Any doubt to anyone in this? We can solve in such questions and will be given. In the question of ionization energy and will not be given. That's it. But more important is you have to understand this thing. कि separation energy और ionization energy का मतलब क्या है? If you understand this thing, then I'll tell you the excitation energy also. All of you understood how separation energy is different from ionization energy? All of you understood how separation energy is different from ionization energy? ठीक है, एक बार चेक कर लेते हैं. ठीक है, let this be n equal to infinity. This is n equal to 1, 2, 3, 4, 5 and then infinity. And let this be your nucleus. इसको मान लेते हैं nucleus. if you are taking electron from here to here, what type of energy it will be? Yes, definitely, Deepika. What type of energy this will be? इसमें कौन सी एनर्जी लगेगी? For this excitation, which energy will be required? Ionization. Ionization. This energy is ionization energy. If I take electron from here to here, what energy will be required? दीपिका, थर्ड से बाहर जा रहे हैं तो कौन सी एनर्जी लगेगी? सेपरेशन एनर्जी. फिफ्थ से बाहर जा रहे हैं तो कौन सी एनर्जी लगेगी? If we are going from 5 to infinity, which energy will be required? From 5 to infinity, separation energy. Second to infinity, which energy will be required? Second to infinity, separation energy. Understood? Understood, all of you? ठीक है, तो we have understood this pathway. We have understood this pathway. What left is this pathway. हम बाहर जा ही नहीं रहे. We are not going out. We are somewhere in between only. We are somewhere in between only. If we are somewhere in between, then that is called excitation energy. Excitation energy. If we are somewhere in between only, then that is called excitation energy. If we are somewhere in between only, then it is called excitation energy. All of you understood this? All the three energies. Excitation energy. Energy required to move from one state to other state. To other state. So what happens if it's opposite, like infinity to n? We do not have anything at infinity. We have electrons inside the atom only. Atom के बाहर कहाँ कुछ है? How we can assume such things? ओके प्रत्युषा, आपने 12th क्लास में इलेक्ट्रिक फील्ड वाला चैप्टर पढ़ा होगा फिजिक्स में. There we take a point charge from infinity to the electric field of other charge. Those kinds of things you can assume, but यहाँ पर वो applicable नहीं है, as we are talking about the electrons which is present inside the atom, which are not present outside the atom. Okay. So your energy is moving from some initial state to some final state. Some initial state to some final state. So I should say that delta E will be minus 13.6 electron volt into Z square by N of final. So for this excitation energy, it's always from lower energy to higher energy and not opposite. Yes, obviously. If we are talking about energy required, then it cannot be opposite. Because whenever we go from high to low, then only low to high, then only energy is required. Excitation energy will be positive. That means from low to high only, always. Minus 13.6 electron volt into Z square by some n initial का whole square. If we solve it, what it will become? ये minus minus plus हो जाएगा. So 13.6 electron volt into 1 upon n initial square minus 1 upon n final square into Z square बाहर चला जाएगा. That will be your delta E. Any doubt in this? Now n initial should be lower than n final always. Then only you will get positive value. नहीं तो negative value आ जाएगी. N initial should be lesser than n final always. Your delta E will come out to be positive. All of you understood this? Excitation energy, separation energy, and ionization energy. ठीक है. So delta E will be 13.6 electron volt. 1 electron volt has 1.6 into 10 to the raised power minus 19 joule. Do we know this? 1 electron volt is 1.6 into 10 to the raised power minus 19 joule. Do we know this? तो इलेक्ट्रॉन वोल्ट को जूल में कन्वर्ट कर सकते हैं. 1.6 into 10 to the raised power minus 19 into 1 upon n1 square minus 1 upon n2 square into z square. This will become your minus 2.18 into 10 to the raised power minus 18 into 1 upon n1 square minus 1 upon n2 square joule per atom. Z square joule per atom. Per atom we are talking about. Always remember this. Okay. So you can use this also for joule purpose. And for electron volt, you can use this. even we know delta E will be equal to hc by lambda. Yes, it have to be because there we were talking about negative energy bounded, and here we are talking about energy required, so it is positive. It has to be same. We are playing with that energy only. तब से हम उसी के साथ कुछ ना कुछ कर रहे हैं. Deepika, yes, it will be same. So 1 upon lambda will be equals to minus 2.18 into 10 to the raised power minus 18 divided by h 6.6 into 10 to the raised power minus 34 3 into 10 to the raised power 8 into 1 upon n1 square minus 1 upon n2 square into z square. इस पूरे को सॉल्व करेंगे तो वी विल गेट 1.097 into 10 to the raised power 7 1 upon n1 square minus 1 upon n2 square into z square. And we know this is Rydberg's constant. Rydberg's constant. Rydberg's constant. We know very well this formula. Any doubt to anyone in this? So this formula is only applicable for one atom. No, it is for single electron species atom. H2 पे applicable नहीं है. Only for single electron species. Because we have not read anything new. कुछ नया तो हमने पढ़ा ही नहीं. Whatever energies we had, हम उसी को घुमा फिरा के कुछ और बना रहे हैं. We have not read anything new. Same things we are applying in different methods and we are getting different formulas. Understood, all of you? तो ये आपका वेवलेंथ हो जाएगा और यू कैन से वेव नंबर. वेव नंबर भी बोल सकते हैं. Yes, because Bohr theory is applicable only for single electron species. He didn't know anything about shielding of electrons. He didn't tell anything about the multi-electron species. Tomorrow we can keep an extra class of yours. Morning around 12 or whatever the time it is. Tomorrow we can या थोड़ा सा एक्स्ट्रा कर रहे हैं तो इसमें टाइम तो जाएगा. आपको टाइम कम है. Can we keep an extra class for tomorrow, all of you? In the morning I'll keep an extra class, so I'll let you know. Okay, morning मतलब 12 बजे के करीब रखेंगे. 1.5-2 घंटे की क्लास रख लेंगे so that तुम्हारा थोड़ा I'll let you know प्रत्युष सर. करीबन 12 या 1 बजे रख लेंगे. ठीक है, टाइम कम है और थोड़ा थोड़ा अच्छे से कर रहे हैं तो you have to give more time. All of you understood this? Any doubt in here? ठीक है, तो क्वेश्चंस कैन बी लाइक in A Bohr model of an atom when electron jumps from n equal to 1 to n equal to 3, energy absorbed or emitted will be, it will be absorbed or emitted, absorbed or emitted, absorbed. Emitted क्यों यार दीपिका? When we are going from low to high, it will be absorbed. When we are going from high to low, it will be emitted. Asmita, you have joined very late. आपने almost 45%, 50% क्लास खत्म होने के बाद ज्वाइन किया है, क्यों? ऐसे तो काम नहीं चलेगा यार. सॉरी का क्या होगा यार? लो टू हाई एब्जॉर्ब, high to low emitted. Can we solve this now? Just a formula based question now. Delta E will be equals to 2.18 into 10 to the raised power minus 18 into 1 upon 1 square minus 1 upon 3 square into hydrogen atom. I think they are talking about. It's not given. Let it be hydrogen atom. So it will be 8 by 9 into 2.18 into 10 to the raised power minus 18. 8 by 9 से मल्टीप्लाई करना है कि माया, you have to put the joules value or you have to give the units because here options are given in ergs. यहाँ पर ऑप्शन ergs में दिए हुए हैं. Okay, so when you solve it, you will get joules, and 1 joule equals to 10 to the raised power 7 ergs. Okay, that means if Deepika is saying 1.9 into 10 to the raised power minus 18 joule, तो ergs में हो जाएगा 1.9 into 10 to the raised power minus 11 ergs, and this will be the answer. Understood? ठीक है, तो अभी इतना करते हैं, रेस्ट विल डू टुमारो. दैट इज इट फॉर टुडे. Tomorrow we'll do the atomic spectra and de Broglie equation. If possible, Heisenberg also. I'll keep a 2-hour class tomorrow. Do not miss it. अस्मिता, देखना आपको यार जिस टाइम शूट करता है आप उसी टाइम रख लेंगे क्लास. Do not miss it. Okay. That is it for today. Thank you.